Good. There will be some latency. Let's start. Hello everyone, welcome to our third AI's third one, right? Third one of our AI video. For those who doesn't know me, my name is Fatih Turgut. I'm a cloud solution architect here in Microsoft. I am basically mainly focusing on the application development, application DevOps, DevSecOps, and Azure application development, and of course AI development. This is what my objectives in Microsoft, what I am doing. I have been Microsoft in the last 15 years, and before Microsoft, I have been working other companies back in Turkey. As you can understand from my accent, I am from Turkey. And I have been working in that industry last 22 years. I have a colleague with me here.
Hi everyone, I'm Sirmad Raza. I'm also at CSA. I recently joined Microsoft 4 months back, and I welcome you all.
Yes, and we also Sharsha here. You all know Sharsha from our previous stations, and our dear Fatma is also from our team. So, and we're gonna have one more. Another Sarmat will join us, hopefully. We need him because he's the one who is gonna order the pizzas. If something happens to him, it means that we're gonna be hungry. So pray for him to come here as quickly as possible. Okay. Who is here as a first time? Good. All UBS. Cool. Okay, so this is as we mentioned, this is our third session in this series, and in first two sessions we talk about the fundamentals of the AI, what's going on at the background, how these large language models are working at the background, and now today Sarmat and myself will go into some practical examples, how we can deploy these large language models and how we can create our own applications. That's the aim of this module. There's one more space here if you want. Here, there's one more space. So, let's start with the basic demo. First, we would like to show a very basic demo, what a front-end application, which is using a large language model at the background or Azure OpenAI at the background, how it looks like. Then we will go into the details. Sarmat will help us on this.
So guys, we have like several demos that we're going to show you. This is the first one. This is like a very basic demonstration how we can utilize Azure OpenAI endpoint and simply chat with it. So this application that you see is basically just calling the OpenAI endpoint, and it's just a simple chatbot. So basically, if you ask it a question like capital of Qatar, it responds with the answer that the capital is Doha. So basically, it is calling Azure OpenAI and getting the response from that. So I'll just show you how the code looks like. So this is a Python Flask application, and this is like all the minimal code that has been written to get this functionality.
Sarmat, can you please zoom in with Control Plus? Yeah, that's better. So we are not expecting you to understand what this code is doing at the background, but basically, I will explain what we are doing at the background, basically. So we have an OpenAI service running on the Azure Data Center. This is a global service. And the responsibility of the service is to take our questions, think about it, and then respond back to us. And the protocol between this AI and my web application is a REST API. It means it's an HTTP, basic HTTP or HTTPS, right? If it is in the, if we want it to secure, we will make it HTTPS. So that's the basic idea, how you integrate your applications with the Azure OpenAI. So we will get into the details of the architecture. So this REST API standards gives us a flexibility that we can implement the same idea for any user interfaces. In this scenario, we are using a web user interface. In another scenario, you can create a Microsoft Teams application and then use the REST API and integrate your Microsoft Teams chat with your OpenAI. In another one, let's say you have a mobile application. As you know, all of those mobile applications is also support this HTTP request, right? It can send the HTTP request to the OpenAI and response back the results. So you can think of any user interface which supports HTTP requests or REST APIs can use this Azure OpenAI. Are we clear? Now, if we switch back to the slides, now we will get into more details how it looks like at the background on the server side. So this is a basic architecture. We keep it basic because we don't want to bother you lots of details at the beginning.
Tim, can I just, Samarth, will you be able to pause that room as well? I'll set it up there as well because we have around 12 people.
How to do that?
Forward the meeting from your laptop.
You guys can stand for now. I'll set up your meeting here.
Guys, if you want, you can stand up. You can join the meeting in another meeting room, or you can come here and sit down the carpet if you want. It's up to you. Anyway, so this is the basic architecture. So let me explain what we have. We have a user which starts the transaction, right? It will do the HTTP request to our web user interface. This is our app service, compute service, which is hosting our web page. Okay, it's the user interface and also the backend service. Of course, in a real life scenario, we should have a different front end and different backend services. But for the sake of the demonstration, we will keep it simple and we will just put one app service instance. This is our web application who is welcoming our users. Show this user interface to us, this chat window. Okay, and of course, we have some security on the top, and as you can see, it's through the second item, our Azure AD, which doing some authentication, authorization to keep our application secure, safe, and managed identity. Then it will go to this side. This is another virtual network in our Azure data center. And we have some Azure machine learning.
Can I just interrupt for 1 second? If you guys want to stand here, it's okay, but I've set up the other room if you want to see it from there. The other room is, if you want to sit, you are most welcome to sit. But if you want to stand,
there's also space here if you want to stand.
Yeah.
To open
up
some
to you guys.
Yeah. Than themselves otherwise.
can you say something?
Hello, can you hear us? Mute yourself. We are good. Cool. Now, what other backend services do we have here? We have the Brain here, which is hosting our large language models, right? This is the one who is responsible to answer our questions. And we will deploy some large language models at the background to this service. And the request will come to here and it will answer back to us, okay? Of course, we have other services which help us during this deployment, like Azure Key Vault is responsible to store our secure keys, right? To keep them secure and safe. Another one, Azure AI Search, to keep our database. For example, we want to use some extra data because this large language models is a static data, right? But we want to add some extra data, which we are going to talk about it, right? Then we need this Azure AI Search also. Also, container registries. Maybe we want to deploy some endpoints from here to the container instances. We need a container registry. Again, a detail, don't bother yourself about this one right now. Azure Storage to keep some, again, data file, image, PDF file, text file. It's a storage. You can think of it like a file system. Again, you don't need to bother yourself. This one for now. This is the basic architecture. So where we took this architecture, there's a GitHub page which you can see this architecture, read all of those elements, their roles, and there's also step-by-step instruction to show you how to deploy this architecture into your Azure subscription, and you can try by yourself. So Sarmat will show us to this GitHub repository, and at the end of the presentation, in our LinkedIn group and WhatsApp group, please make us remember to share this GitHub pages links with you so you can try by yourself.
Give me a second, I'll have to stop sharing. So this is like some of the documentation that you can find on Microsoft Docs that explains, each component that is being utilized in this architecture. As Fatih mentioned, this is like a basic chatbot architecture that you can use. It has a GitHub repository where you have, infrastructure as code templates. Basically, the infrastructure as code is a kind of a new technology these days. Basically, you can deploy cloud services using code. So all of these templates are available in the GitHub repository. I'll show you right now. So you first deploy the infrastructure that is native and that is based on this architecture. And then it has a sample web application as well, which can run on top of it. So we'll show you that. So I'll open this GitHub repository here. And so this is what I was talking about. It has this bicep. This is the infrastructure as code template. And then website folder contains the application, which is going to be running on this.
So what you have to do is you have to clone this repository into your local PC. There's a clone button on the top. And then you will see the web application code and also bicep scripts. These bicep scripts, as Sarmat mentioned, infrastructure as code, it means that you don't need to build the infrastructure manually one by one. You can just run those scripts on the Azure and it will automatically build this infrastructure for you. So you script the infrastructure and for yourself, and whenever you need it, you can run it again. It will make things more fast and automated. Okay.
So this has like some prerequisites. You need to have an Azure.
Samad.
You need to have an Azure account. You need to have a role on that account, so you can assign roles to different services. My role is what I mean is that you have to assign different kind of authorization to of the components that you see, so they can communicate and access each other. And it utilizes Azure CLI, which is a command line interface built in Azure. And then the AZ Bicep tool, which is the infrastructure as code utility that is going to be utilized to deploy it. And you can see these are like simple instructions. If you read them and you follow them, you'll be able to deploy everything within like 10 to 15 minutes. Everything will be up and running. So basically, in the first step, you clone the repository, and then you log into Azure CLI by using these commands. And then over here, you create some initial resources, for example, a resource group, which is basically a holder in Azure, which holds your resources. And then once you run this command over here, it will just automatically run the tool and deploy all of the infrastructure and everything. So if we will share all of these repositories and then these links with you, so you can go through them. If you want to configure this deployment, but how it looks like when it's running. So this is how it looks like. So by following those steps, you will end up having all the infrastructure deployed in Azure, and on top of it, it will deploy the application. And once you hit the URL, for example, let me just show you. So if I go to my Azure, over here you can see this is a resource group which was deployed by this template, and it created all of these resources. This is the basic architecture that we have. And it has this app service, which is the hosting platform for the application. And if I go inside it, it gives you a URL, a default domain that you can utilize to access whatever is running on this web server. So this is the application, and now this application further, Fatih will talk about how it is, what other components it is utilizing. But basically, just to let you know, this is targeting Wikipedia. So it picks up knowledge and then data from Wikipedia and replies based on this. So for example, can someone give me a question to ask Wikipedia maybe?
Who is Bill Gates?
Bill Gates.
Okay. Team, just to add a few points, there will be people who are new to Azure. Okay, you will not understand what these components are or things like that, but just understand the concept. And then, for example, if you want to understand or build your own stuff, you can just like check that service and ask Copilot what this service is, so you can get to know that service. You can also ask that, for example, Wikipedia is like a public knowledge. Why would I create like a custom knowledge for it? Okay, there can be two reasons. Once, the older knowledge, whatever is in the Wikipedia, that is already in the memory of this model. Okay, but the model was trained, I think the last one is, I think either February this year or October last year. But what about the new articles? So if you want to have the new article, and it's just giving you a concept, right? Like if you want to create your own, you have your own repository and something like that, and you want to create it, this will just give you a very quick start how you can build your own Copilots from scratch.
So just to add one more thing, so if you guys see, it gave us a response, and with the response, it is showing the source as well. And this source is this is the link on Wikipedia from where it pulled this information. Yes, Fatih.
So let me explain the same idea from a different perspective. Let's say my daughters asked me a question. Baba, which planet has the most moons in our orbits in our solar system? Then I think about it, and I said that I read an article about this one when I was in the high school. I think it's Venus. So there's two problems here. The first problem is I don't have the source, which I can share it with my daughter. Right? There is no source, so I cannot prove it. The second problem is it's not up to date because it was 30 years ago when I was in the high school, right? So that's what we are also facing in the large language models. The data is static. When we train the model, that's the static data. This is the trained data and it stays there. That's why we need up-to-date data. And that's why we need this RAG. We need some extra information from the outside to fetch the data, merge it, blend it, and give it to the end user. So there is two different concepts here. You might also face the same question. One is the RAG. That's what I mentioned here. You have a static data and fetch some data from outside. The second one is fine-tuning. They are similar things in one concept. In the fine-tunings, you will train your data on a specific data set. For example, GitHub Copilot. GitHub Copilot is trained on public GitHub repositories, which means the source code, application codes, right? Its expertise is on the development. It helps us how to develop a code. That's why if you ask the question, let's say if you ask the same question to ChatGPT about programming, you will get a different answer. And if you ask the same question to the Copilot, GitHub Copilot, you will get a different answer. And most probably, the GitHub Copilot answer will be more accurate and much better than the ChatGPT, because ChatGPT is a generalized data, but GitHub Copilot is a fine-tuned on code. That's the differences. And you need to also, when you build your application, you need to choose if you're gonna fine-tune your models or you will use the RAG. How do you choose it? How do you choose that? So you need to check your data. Is your data incremental? Is your data speed of increments is fast or slow? If it is fast, then you cannot do the fine-tuning, because fine-tuning needs lots of energy and cost you a lot. Because when you do a fine-tuning, you will train the model again every time, and you spend lots of GPU energy, electricity, right? And you pay a lot. So for example, GitHub Copilot, it's trained 2023, I guess, or 22, and still they haven't trained again. We are in end of 2024. They are gonna do it again, but we don't know when they are gonna do it. They are not announcing it because it's very costly, because we are talking about trillions of the data to consume lots of energy. That's why when you decide if you're gonna do a fine-tuning on RAG, you need to check the data, the characteristics of your data. If it is increment, is it fast data or slow data? If it is slow, you can use it. For example, you are working in the Ministry of Dutch. What are they? Ministry of what? Yes. Justice. Ministry of Justice. Let's say their data, they can train their data with a fine-tuning. So when the judge search a similar cases, right, he can find it because the cases are not that much, and they are, most of them, they are similar. He can help it. So fine-tuning might help it. But think about a e-shop store, right, which you are indexing the products, catalogs, right? They are adding new products every day. So you cannot do a fine-tuning every day. You don't have such capacity. In such scenarios, you need to go for the RAG. Okay. Now, here in this demo, what we are doing RAG. We are using large language models. On top of it, for the up-to-date data, we are using Wikipedia. So how we did it, if we switch back to the background, are we clear, by the way? Any question? What is RAG, what is fine-tuning? Good, right? Okay. So if we go to the this is what machine learning. Okay, if you can launch the studio. We have a machine learning studio which helps developers and machine learning engineers to design their background services. It's like a designer, user interface designer, which will help you. As you can see, there are tons of easy, quick startups that you can use it in the main screen, and some samples, some helps, so you can check this one. If you go into the prompt flow, what's prompt flow? Prompt flow, you can think of it as like an orchestrator, which will help you to design your flow in a visual way. Okay, so you can blend your large language models with the Python codes and with other sources, and you can design your flow and you can publish it to your customers. For example, let's see the screen first. If DemoGuts allows us to see the screen, we will see it. Maybe you need to log in again, Sarmata.
Meanwhile, I'll ask a question. The question that we asked, like the previous one, someone is working on this. It asks a question and just return a value. How is it different than a normal search? Like you can search this in any search engine and it will just go to the Wikipedia and just read it there. How is it different than the search engine itself?
So he summarized it.
Yeah. So you ask a question, you don't have to read the whole article. That's the advantage. Okay, because you ask direct question, it will give you direct responses. It knows from this article what you are looking for. If you are looking for some dates or names and things like that, it will just summarize that information. You don't have to read the whole article. So, like for example, if you have, let's say, 3 pages of document on Wikipedia, you might ask a question which is just for one section. Or it might be that, for example, the answer is in 3 sections. So it will combine that and it will let you know what you are looking for. And that is the advantage that the traditional search engines are getting obsolete, because you can directly ask a question. It will respond rather than you just search in the engine and then you just look for the links where you can find this answer.
But I'm having some permission issue.
Are you able to create a new one?
No, I'm still able to, not able to do that because it's not able to access the storage account. For that,
The storage account, just change it, the configuration to use the key. Go to the storage account, if you can go there. The backend storage account. On the resource group, you'll be able to see. Yeah, go to the resource group of the AI. It should be a storage account.
Maybe the second page.
Yeah. So there's a lot of security enhancement that is happening that, for example, you cannot have anything which is key-based access. It's just converting everything to be user-based. Configuration. Down to configuration. Yeah, configuration. And there should be an option, allow storage account with key enabled. Third last, yeah, this one, and save it. And try it. All this done.
So they recently changed this policy in Microsoft also. So we are also facing this kind of errors in Microsoft. Yeah. Hopefully it will work.
We faced the same issue in our hackathon
What's that?
last month.
Huh?
We faced the same issue in our hackathon. We had
Yeah.
the hackathon in EBS last month, so same problem.
Okay, good. So what this one is, this is the chat with Wikipedia. Maybe, Sarmat, if you can first go to the click a new flow, create a new flow screen so they can see it from flow. So he clicked the prompt flow, and then when we click,
This is how you can simply create a prompt flow and use a template to use for it. So we did the same. We wanted to chat with Wikipedia data. So for that, you just have to clone this flow. And let me just give it a name.
There are also other templates that you can use. For example, you can use your own data. Let's say you have PDF files and you want to use those PDF files. You can, there's a template for this one also. Automatically go and check your PDFs and give the answer by using those PDFs. We have also sample for this one. So what you will see is, this is the flow, our graph diagram. It will start with the input. It will collect our inputs. So if you click the input, Sarmat, the first one, so it will take us to here. This is our first part, input part, okay? We have the chat history and we have the question. And this is the default value of the question. You can change it. Then the output of the input goes to the other elements in the flow. If you click the second one, extract query from the question. So this is the LLM tool. So we are communicating with LLM here. So which LLM are we communicating? There is a connection drop-down list on the top. If you open that one, this is our AI, Azure OpenAI service, which we already deployed. Our templates, Bicep templates, automatically deployed for us. So I will check this one. I will choose that one. And then it will ask which API I'm going to use. It's going to be chat. I have GPT 3.5 deployment at the background. And then the response format will be, if you can open the drop down for the response format, here, this one. We'll choose if it's going to be a JSON object or text object. Okay. So with that, we configure this LLM module in my flow. Then we have a Python code. It will take the output from here and it will go to the Python. It will do a search. If you can zoom in here, you see it will go to the control one. If you can make a zoom. Sorry, I am good. Come here. Yeah, this one, yes. This one. You see, it will go to the Wikipedia and make a search. And the search result will give us two URL list. So for example, when he asks, who is Bill Gates? This LLM take the keyword of Bill Gates for me and give it to the search entity. It will put Bill Gates here. So it will take the output to URL. And then if you can zoom out, scroll down on this one. Don't bother yourself. It will go and make a request, take to URL. Then it will go down here, search results from URL. It will make a request to this to URL and fetch the text from the page. Basically, it's crawling the web page for us, right? It's crawling the web page, and then it will take this context, text, and process them, merge them in an array, and then finally it will go to another LLM, again the same LLM, and give this text and say that please summarize this text for me and create a meaningful output. If you click that one, as you can see, the system message. You are a chatbot having a conversation with a human, given the following extracted parts, blah, 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 blah. Please summarize the result, and also always return a source. Give the source. Then LLM will get the context. Context comes from the Python. Get the chat history from the chat itself, and then it will generate the answer for me. That's the flow. Okay, is it clear? So as you can see, this is a flow. So if you see the plus signs on the top, LLM, prompt, Python. Let's say you want to change this flow. You want to add an if statement. You want to add another LLM. Let's say you want to do a length chain, right? You want to use different language models for different tasks, you can do it. You can add another LLM, let's say, search, right? For the aid, there's another LLM for searching, vector index searching, ADA something, I forget its name. You can use that one, right? Let's say you can add another Python code and you can do some custom things on there. If statements, switch statements, all of them. That's an orchestrator. Then, after we design our flow, then we need to test it, if it is working or not. How are we going to test it? You see on the top, there's a start compute session. You start compute session. It starts a compute engine, a processor at the background to run this flow for me. It's a serverless. There's two options. It can be serverless, or let's say you already have a compute. You can use that one. But in that case, you don't need to use your existing one. If you click that one, it will start the compute session, but it will take 5 minutes to ramp up this compute instance, and then you can use it. And then after this compute session started, you will see a chat window here, which you can chat, which you can test your flow, if it is working or not. Clear? Good. Now, we create our flow, right? We integrate it with the Wikipedia. We test it. Now, what's next? Exactly. So we need to deploy it, right? Otherwise, how my customers will use it, right? How are we going to deploy it? You see, there is a deployment icon here. It's a cloud. Yes, first you need to start this compute session. After that, this deployment icon will be. When you click that one, it will ask you, do we have already deployed one, Sarmat?
Yes, we
Can you go back to that one?
This one is already.
Yeah. Anyway, it doesn't matter. So what it will happen is, you see on the left-hand side, there is assets. We can see that there's a compute section here. Sorry, if you can go to the compute, these are my compute instances, which is running at the background and publishing my endpoint. As you can see, I have one compute instance running right now. Okay, so when you deploy it, it will ask me if I want to use an existing compute instance or I want to create a new one, serverless one. So there are multiple options here. You can use any compute service in Azure which supports containers. It can be container app, it can be container instances, it can be Azure Kubernetes services, it can be application services. Okay, but we will get into details on those options also. Another important point here, if you go to the endpoints, after you deploy it, you will see a public endpoint over there. This is my managed endpoint, which is backed by my compute runtime. Okay. So if you open this endpoint, can you click this endpoint? You will see your endpoint detail, managed online endpoint. And if you go to the test consume, you will see some details on top on this endpoint, your keys, code, how you can integrate it with your code, different JavaScript, Python, C#. You just need to copy and paste.
Can you just scroll down a bit?
Yes. Sarmat, can you scroll down a little bit?
This area. So it gives you different code snippets that you can use and integrate, within your application. So over here, we're mostly talking about the backend orchestration that is happening. So in this, I mean, I just would like to, go back to this slide and just add a few points. I mean, this will give you a better understanding. So this is, as you can see in the step 3, there is a managed online endpoint. So this is the endpoint that Fatih was mentioning. This endpoint is running on a compute layer. These can be virtual machines, function apps. These are hosting services in Azure. So this endpoint is available on this compute. And the front-end application, which we saw when we asked who is Bill Gates, that takes the input from the user, sends it to this endpoint, then this endpoint takes that input and runs it through the flow, which we saw. And then based on that, it grabs the information from Wikipedia. And this is the overall flow in this diagram, which you guys can see.
Yeah. So if you switch back to the screen again. So as you can see, if you scroll up a little bit more, this is my REST endpoint. So you can take this REST endpoint, you can place it into your mobile application, Teams application, web application, Windows application, wherever you want, which supports REST, and you can use it. The rest is up to you. Right? The user interface. Yeah.
In the flow that you showed us, is it limited to Python
Yes,
only?
limited Python, I believe.
And when we write those scripts in Python, so do we expect something like an input-output format?
Yes, there are the input and output over there. I didn't get into the details. Did you order the pizza? We are not going to get that.
What time you finish?
Hopefully 1 hour late, 2 hours later.
2 hours later.
We'll finish, inshallah. Yes, here, if you can see, look, can you scroll down a little bit more or not? You should be able to see some output and input here. Yes, you see the input. These are the input question. Where this one coming? From the input. This is the LLM. It takes the input from the question, the user question. And the output will be here, somewhere here. So there is a fields which show your input out. So you can take, of course, otherwise, how are you going to run this flow? You need to take the output of the previous one as an input, process it, and move to the next one. And this user interface supports. If you want, you see the raw file mode. Can you open the raw file mode? Somewhat. Yeah. If you want, this is the raw file. Or if you want, can you switch back to normal? Can you expand the files on the top and the files? Just below here. This
Yeah,
one.
okay.
Download. There's a download button on the top. To download it as a zip, you can go to your local PC, open Visual Studio Code. There is an extension called Prompt Flow. You can open this zip file in Visual Studio Code, open this prompt flow. You can develop this prompt flow in your local PC. But of course, you need to do the connection from your PC to your OpenAI. Okay, so may I show this one?
Yeah.
You have this Visual Studio Code, right? Yeah. So if I go to downloads, right click and extract. Isn't install? Okay, no worries. So right click here, show more, open, no. Another one. Folder. Downloads. This one, right? It will open it here in Visual Studio Code. Yes, I trust. I will go to extensions, search for
Which I would like to. No, go ahead. Two questions, which were asked in the other room as well. One was that, the chatbot is responding very slow. Why is that? Okay, so usually there are different type of models. And each model has different type of, performance, response time. Even if you see like you, for chatbot, you don't expect millisecond latency. It will be in seconds, but how many seconds? Whether it should be 3 seconds, 10 seconds, 20 seconds, depends. There's a lot of factors which contribute to the performance. What is your answer or your question first? How much is the knowledge? Okay, and these all counts. If you remember my first session where I was giving about the tokens, the token counts. Okay, then secondly, each response will have some overhead. Okay, and that all builds up to the things. There will be some time that you will say, oh, this is not even responding to what I'm expecting. Okay, the service that we are using is a free tier. Okay, so if you want a response, you have to at least pay something. Okay, this has a simple answer. Yes, please.
Now, the problem flow, I didn't see any task or step that will handle the intention, the language. Let's say will handle the correction of typos, grammar mistakes. This is all built in, or I need to have it in my prompt flow. So if I put Qatar without an A, for example, or
Yeah.
you got my,
Yeah.
where is this handling happen?
So there can be multiple parts. If you make a mistake, either you have to handle it in the application. Okay, the application needs to first handle it and send the clean data. Okay, sometimes the AI model will be intelligent enough to even understand the context. Okay, the context means if you already have like a knowledge and there is a few mistakes, I have tried it with different spelling mistakes, it will work. Okay, but usually in the application layer, when you are sending the question, you should actually do a spell check and things like that. Should do it more accurately as well. So you have to call other services to correct it.
Validator.
Yeah, validator, corrector, spelling checks, grammatical thing, like even if you just like, if you are using the knowledge base as let's say the AI search, when you start typing, it will suggest, do you intend to mean this? Okay, so you have to use some other layer on top of it to get the spelling corrected.
Right, so within the flow, can you run parallel tasks at the same time?
I think so. There is a flow. I think, yeah, if you see the flow, there is two parts. Like if you see here, this is kind of like parallel, the input, but there can be multiple tasks. I think we can do it. Or if not, you can run two simultaneously threads separately and then combine it together. Okay. There was one other question on the language. In here on the prompt flow, I think only Python is supported. But when someone can just go back to the actual the prompt flow or the things where we were seeing the languages.
JavaScript was there.
Yeah, so JavaScript, there was a few others. So, yeah, so multiple languages are supported. Okay.
But that's for fetching, like
Yeah.
making the API call.
Yeah. So that's why I said that there is multiple things that you need to be aware of. If you see here on the top, there is usually Python. If you go to the compute part, I think there is the language. Yeah. So I will check, like I'll respond back to this question. I'll check and respond back which languages have supported where, but this is one of the questions which I'll respond. The YouTube channel.
Yeah, you can export these files as Python files. Can you import Python files into this user interface?
Yes, I think like you're saying that the prompt flow, right? Like if you have created the prompt flow and you are doing like import and export.
This is a plus sign here. If you press that one, you can also upload your files.
Like if you want to move it to a different environment, you can definitely do it.
We have just only one source right now we have added, but what if we want multiple sources for getting this information? Right now we have just added Wikipedia, but I want.
You see that there's LLM plus here. If you press this LLM, you can add another LLM here in your graph. So you can have multiple LLMs or multiple sources in your graph. So you can use or prompt or Python. You can use these tools to enlarge your flow.
But the final output that we get, how it will.
Again, it's up to your logic. So you need to finalize them, merge them in a single output, because there will be only single output. There should be. And you need to show it to the end users. It's up to you, again, the developer's responsibility to summarize all of them and then present it to the end users.
So I'll respond to this a little bit more, okay? If you have, let's say, 3 sources, okay? And you have priority, that this source is the first priority where I should check my knowledge, okay? First, ask the questions to that. It will respond back with some documents, okay? If you find that, for example, I don't know how many people have attended my first 2 lectures, okay? But I was giving the concept of vector databases and the search and everything like that. The first thing is, if you have like source 1, you ask your question and get that. If you have a high similarity or a high score that there is a knowledge farm, just go ahead, send that knowledge only to the AI model, okay? The other thing is that there is a miss. There is nothing which is returned on that source, okay? You can change this process, and this is what LangChain and things like that is, that you just stop there, you go to the next source, then you go to the next source. So that, like normally in the process, what we do is we use for our own knowledge, okay? If there is no response, we go to, let's say, the Bing knowledge. If not there, let's say we go to the memory of the model directly, then it can respond something or not. So this is how you can chain together.
The data needs to be fetched from database, for example, not any Wikipedia or any other
Yes.
source. So how it connects to database?
Yeah. So very well question. This was, if you probably you were not in the first section. If you just check the first 2 sessions, I've explained the concept of vector databases. And for example, when Sarmad and Fateh was explaining about the knowledge, what you need to do is you take all the knowledge, put it in one consistent database, a vector database, and that will become the brain. For example, that whatever question you ask, it will only come from there. Okay.
We have one demo about this one also. To use a vector database, upload the PDF files and use a vector database. So it uses it as a source.
I'll just give
Another-
another. These are 2 sources, okay? Source 1, source 2. If you want to answer this from these 2, you just combine them, give that as one in one database. That's as simple as that.
Another real life example, for example, in GitHub Copilot, if you ask a generic question, let's say, how are you? There is a filtration in the GitHub Copilot. It will not take this question and send it to the this LLM code optimized LLM. It sends it to the normal Copilot. An answer comes from the normal Copilot. But if it's a code question, it goes to the Copilot code LLM.
Now, again, back to the intention check. Let's say, for example, in my company, I want to check what is the leave policy and what is the leave policy. It will go and check the leave policy. Now, what is my leave quota remaining for this year? Then it will call some web service, go to HR data, and tell me you have 10 days remaining in your balance in this year.
Yes.
This routing, again, in the prompt flow, it will.
Yes, with the
So I need to build it myself, or it will detect that this is coming from my LLM. I need to go there.
I believe it should be the one that you need to agree on. Again, as in LLM, data is static, right?
So
But the question is, it's not a static. The answer is not static because you are asking the up-to-date remaining vacation dates, right?
That's the second question. Third question is leave policy. Leave policy is
It's static, so you need to. I don't know how we're gonna find it. Do you have any answer?
So if you ask the question, consider as a normal flow, right? If you ask one question, what is the policy? How much my leave is remaining, and how much is something else? This is just a complex question. You have 3 tasks in one question. Okay, this can become complex, and if for each question you have a different knowledge base. So what you need to do is, like as a normal person, when anyone is chatting, they will not write this much complex question. The first they will ask this question. Okay, you can do multiple things. If your knowledge repository is consistent, okay, you just throw that question and it will return the results. Okay, if you have 2 structure, one is your HR policy and one is your structured data, how much leave is remaining. This is an API call. This is your text. Okay, this is personalized. So what you need to do is you just need to first ask, who is this question? Like, for example, if I just say your name is XYZ, okay, XYZ, first extract all the information for the current leave. This will just give you your personalized information. And then the HR policy and these 2 combined, you just send it to the AI model as one knowledge. Then whatever question you ask, both knowledge are now in a single document and they will respond back accordingly.
This is handled in the code, not dynamically.
No, not dynamically, because you need to send the question from where it can be answered.
You can actually extract the intention from this. So when you have an intention, based on that intention, you can like have those parallel flows. So let's say from the intention, if you see that, okay, this is data should be coming from a database, like it is a personal data, something like that. So you can have a flow in that manner.
You can also create different agents for different purposes. There is one agent which is just identifying the intents. Okay, so whatever question is asked, you don't respond to that, you identify what is the intent. Okay, then that intent will delegate it to which agent it's passing. And this, if you have multiple hops, it will add to the latency as well. Okay, so based on the application, you have to like take a decision, but it's all doable.
There is actually a ML service to get the intent in Azure. So you can like train it with your basic data set, and based on that, you can get the intents from the test data that you want. Kind of, you can have an 80-20 training and test data set to get an intent out of it.
Yeah.
So maybe my next question is that whether we can connect different services in this flow or not.
Yes. So if you go to the connections here, for example, we will show you, but if you go to the connections, you can add different modules or connections here. For example, what we have Azure OpenAI, we have AI search, and we have blob storage. So different connections you can add, and you can use those connections in your flow. If you click the plus connect button on the top, you will see different providers, connection providers. For example, Azure AI services, for example, to understand the intent of the user, maybe you can use these AI services to understand what is his intent. And then according to his intent, you can redirect the flow to the different directions. Azure AI speech to text, text to speech kind of operations, right? Serverless model, and there are other types of the resources that you can use it in your flow. Okay, you can use those connections.
I have a question around security. Let's say I have HR data and I want to access, let's say I have some personalized query, let's say how many leaves or something related to
Yeah.
me or something. So how this is handled, or how authentication is taken care of?
Yes, first of all, authentication is must. That's why we have these authentication providers over there. And in your flow, again, you need to find a way. Of course, there will be way. You need to take this identity of this user who is asking this question, especially in an enterprise scenario. If it is running in-house in the organization, you need to take the identity of this user and you need to define a borders for him, for itself, right? He should not able to ask question for someone else, or you shouldn't allow him to ask questions about Fatih. It should be only his data. You need to apply this privacy rules. I don't know if you have.
This is a simple example. You have
It should be user specific then.
Yeah.
Yes.
Identities are good.
Yeah, so you have to decide whether your scenario is I defined a particular user in your corporate. So consider this is my personalized information and this is Fatih's personalized information. If you are anonymous user on the chat, okay, you will have to put in the logic that, for example, nobody should be able to return. You have to first log in. You have to force the user to log in. Once they are logged in, then you have the personalization. This is my user or this is this. You only query that data from the application which is personalized to that. And you can apply row level and column level security as well on the knowledge base. And the same, like there is different type of scenarios we have. This is HR data, this is marketing data. Okay. And you can create that in the tags in the actual vector databases that this is when this user or this persona is there, only show this information, otherwise show this information. So even if their question is valid, if they are not authorized, they will not see a response.
Be like personalized in the vector.
Yeah.
So if you're going to be implemented.
Yeah. So you add the tags. You add the tags that, for example, the first thing is when you are asking the question for the vectors, okay, you just consider that you partition your table horizontally, okay, and you ask that, for example, whenever this query is coming, you already pass. Let's say a simple example. So let's start from knowledge base. where user persona is equal to something, and the user persona is coming from your login. Then it will only show that, because you cannot show the results record. Is it clear?
Okay.
The endpoint that you had showed earlier, right? So how do my application know how to authenticate that particular endpoint? I mean, like
There's an
tokens.
API key over there. Can you go to the endpoint one more time? In the configuration, it will ask an API key.
So it's always going to be the key based for this. Okay.
You see the primary key, secondary key for authentication. You need to send this data with your header request. Otherwise, it will reject. It will not respond back to you. Okay. Good. Okay. Now we can switch to the base architecture, the second architecture that we have.
And these architecture, just to add, we start from simple, but it's becoming complex, because with corporate scenario, you put security, you put everything. In the next session, next week, okay, we will build this architecture from totally scratch. And I'll ask these questions from you, and we have to build it together.
Okay. What we have in that architecture, as you can see, it's more complex than the basic one. Again, it starts with our user make a request. Now we have an application gateway. It is for the protecting our application from the attacks, right? It also includes some WAF inside it, web application firewall, which will protect us to known attack types, right? Like SQL injection, denial of services, so on and so forth, whatever. It will protect our system from those kind of attacks, right? This is the first protection. As you can see, we have different borders, different blue boxes. Each of them is different network borders, like virtual networks. And each of them is talking between each other with the private endpoint. What does the private endpoint means? It means that these network addresses are not accessible from the outside. It will be only accessible from the inside. It means that this first network can access to this one in a private endpoint, only inside. Okay, this one inside. No one can access them from the outside. With that, we block any request from the outside to our backend services, protecting them. And also, we have this managed endpoint here. Again, the same managed endpoint. We have some compute clusters here. Then private endpoints to connect to the container registry, storage, Azure OpenAI services, and AI search services. As you can see, this one is more secure. Now, on the front-end side, we have our application services, which is our front-end web applications, right? And then the request came, our application firewall, it will do the routing for me and take the request and send it to the front-end web servers. And we have three application service running in three different zones. So why we have three different zones? Because we need to protect our application against two data center disasters. So each application service is in another zone. Each zone is another data center. Distances between 100 kilometer distances, something like that, right? Some 100 kilometer distances between each other. If there will be a catastrophic failure in one of our data center, then the other second zone or the third zone will continue to respond to the requests. Now, if you click one more time, move forward. Go back. Move forward. So what's the difference?
It's replicated the same thing.
Go back.
Search,
Where are they coming from? What is gone, what is come? But where these zones came from?
Different regions are there.
If you check here, we have machine learning workspace, but there is no endpoint here. If you go to the first one again, the previous one, Yeah, you see the managed online endpoint here, and there's a compute clusters at the background. This service is not a zonal service. It's running on a single data center. So it's a single point of failure, which means that if there will be a disaster in the data center, you will lose your endpoint. In order to protect our systems, AI systems, endpoints from this kind of disasters, we can deploy these compute clusters in a different compute services. As I told you, half an hour ago, I told you, any Azure services which supports container runtime can be used as a endpoint compute resource. So if you continue again in our basic baseline infrastructure, what we are doing is we are also deploying our endpoints as an application service in 3 different zones. It can be AKS also. It can be container instances. It can be container applications also. In this scenario, since we already have the app services, we are using the same app service instances and same application hosting both the web application front end and the endpoint. But again, this is not also the production ready architecture. Okay, this is like intermediate architecture between the production and the demo one. Are we clear?
Yes.
Any question?
We deploy the endpoint to consider multiple zones. Are we creating multiple copies of it, or is it still the same?
We are talking about this scenario, right?
Yeah.
Yes, 3 different copies running in 3 different data centers. And another important point. Let's say you decided to not to deploy it as this way, right? You want to still use this compute instances in the previous one. What you need to do is in that scenario, you need to think about the regional copy. If you, yes, this one, this compute cluster, if you want to use it as a compute cluster, then what you need to do is you need to take this Azure OpenAI service and this managed endpoint, and you need to deploy it to data center in 2 different regions. If one region goes, the second region will continue. And you need to put a load balancer, like a traffic manager kind of load balancer in front of these 2 regions. And you need to put a health service. It will check if your endpoint is up and running. It will send the traffic to that endpoint. If the health service will return you that 404 is not working, then the traffic will redirect to the second region. There are different rules over there. You can do round robin, and you can use against latency, so on and so on. Question? Clear?
What about the jump server that we have?
This is
Just,
you just log into Jump Server and you do the development inside this Jump Server. Classic Bastion host kind of thing. Good. Continue. Okay, before this one, do we have a demo before explaining this one?
Yeah, I mean, we have a demo.
Did we, or after this one?
But you can explain this.
Okay.
Absolutely.
And this is the enterprise-ready architecture. Of course, there are more details behind this one, but we will keep it as a simple. What's the difference here? The biggest difference, this part is pretty much same. Can you zoom out, Sarmat? This blue part is pretty much same from the previous one. Okay, but this part is different. This, we called it hub-spoke architecture. We are deploying a hub network. This hub network is for controlling everything. Whatever comes in, whatever goes out, it will go into this hub network. And if you have multiple spokes, different workloads, they will communicate between each other through this hub virtual network. Hub is a control center. responsible from the security, responsible from the traffic, controlling everything, monitoring, logging, everything is happening on the hub. And our Spoke is only responsible to do the business. And as you can see, it's pretty much same from our previous architecture. And I believe next week we're gonna get into details with this architectural kind of things in infrastructure part. Is that clear? Good.
So build this architecture next week from scratch, and I'll ask the question, you will build with me. So we will, I'll ask question and you will tell me which service I can put, what is the benefit, why we cannot put the other service. And it will be a little bit of different than this because it will have a Qatar flavor. But yeah, hopefully we will come up with this together.
Yeah. If you switch one more, let's talk about this Qatar flavor one, since he mentioned this Qatar. This is a Qatar, part of Qatar reference architecture. It is not up to date, but there are some items that I want to explain it here. As you can see, we have a front-end application tier, back-end application tier, and we have API management. We are using this API management for throttling reason. API management can put some throttle in front of our endpoints, public endpoints, OpenAI endpoints. So let's say you have an endpoint and you are receiving millions of requests. So you cannot handle it, right? You need to find a way to throttle it, to stop it. This endpoint doesn't have this feature out of box. It's just a REST endpoint. Whatever comes, it will try to respond back to it. But if it comes like you think of it a pipe, but you are loading this pipe lots of requests, and the pipe has a limitation. It will not fit in the pipe, right? So we need to find a way to stop these requests. That's why we are using this API management. This API management has also a WAF feature, Web Application Firewall feature, which will protect your backend APIs, which throttle the request, and if needed, stop the requests and protect our backend services. It can work as a circuit breaker. So if you feel that there's a denial of service attack, you can cut the circuit, right, to protect your backend services. That's why we put it here in API management. Also, we have a function app at the background of the API management. Why? Function is a serverless architecture. You don't need to set up any compute service at the background. And the purpose of this function app is only go to the OpenAI, ask the question, get the response, and return back. You don't need to build a service account for this one, a compute service for this one. Also, this function apps has a built-in Azure OpenAI binding feature. So you don't need to set up a connection between the OpenAI. There's a out-of-box OpenAI binding in the function app. In that point, it also helps us to communicate the OpenAI, ask the question, get the answer, return back to the client. And it's cheaper than the other compute services. Again, when you...
Question, do you know what the difference between app services and function? How many of you work with it?
Serverless. Serverless, yes.
Serverless, it means that you don't need to manage.
And people who are not aware of this service, please ask question. Okay, we are at different level. So don't hesitate that you don't know something and you might not ask. Ask the question. That will clarify maybe other people. Even I don't know all the services myself. So
Yeah.
To keep our question.
Yeah. So, and also from the cost perspective, it's cheaper than the compute services. That's why, again, when you design your architecture, it depends what customer is expecting, what is your capacity, what is the expected traffic, right? How much money do you have? So you need to consider all of those parameters, and then you need to design your architecture.
A bit of topic, but
Let's take a question from the other room. I'm sorry. Yes, please. Thank you for the feedback.
Thank you. Yes, yes. sorry.
So basically, right now, all the OpenAI models are available in other regions, not Qatar. Is there any idea on when they might be available in Qatar?
Yeah.
So,
This is actually a big, it's a
yes,
big
yes.
obstacle to use the
Yes.
services.
So there are two things, right? Like, for example, I'll explain why it doesn't require you to be in Qatar. Okay, I'll explain why it doesn't matter.
Shasha, we are recording, careful.
Yeah,
It's going
that's
to
fine.
all night.
That's fine. That's fine. No, I'll just say that, for example, why it doesn't matter the region, because this service is stateless. Okay, it doesn't retain any memory. Okay, it doesn't retain any memory. So even if you're sending the data to it, it doesn't retain. So it doesn't matter if you have like in one region versus the other, because it doesn't know what you have asked, because it will just discard that information. Temporarily, you will send the data to the other region, but it is also on the like the backbone of the data centers, and you put the security controls like what Fateh was showing in the other architecture. That's why the network security controls are there. So even if it's in the other region, it doesn't go out of your control. Okay, that's the first question that should not stop you from putting the workload on the cloud, even if it's in the other region. Okay, the other thing is when it will be available and things like that. There is already coming like on the things. We will be like working on that. I cannot do it on the public, but yeah, it will be coming. And the other thing is, as I mentioned, if you have workload and that is like stopping you from security or anything like that, involve us. We will help you out why this doesn't matter if you have this service in the other region as well.
Okay, gotcha.
Sure.
Thank you so much.
Definitely.
Yeah, because, because her question, I'm from a fintech company, and I would like to use this AI tool that
Yeah.
it will help my merchants to investigate about their sales happening through
Sure.
my gateway. So one of the regulation of Qatar Central Bank is to keep the data here in
Definitely.
the region.
Yeah.
That's why even I cannot send anything outside. I stopped all my before I came to Azure, I was in AWS, and plus I was in UAE with Azure also. Two services I have.
Very good question. So there is like regulated question multiple times. Okay, the security question will come in two flavors. One, irrespective of the region first. Even banks and everything, they don't trust these models. They want to know more what is happening with these models. Will my data will be used or will it be retrained and things like that? That's why the difference, like what Microsoft is providing, Azure OpenAI service, because it's your compliant in there, it is not going to use that data for any other thing. It's in your own tenant. Okay, and everything is logged. Whatever you are asking, we can provide the privacy. We have a privacy section where you can just see this whole thing. Now coming to the region part, very well point. There is a lot of industry which are not able to send this data outside of the region. There are two solutions. Either, for example, in exceptional cases, okay, exceptional cases, either you don't send the PII data to outside of the Qatar. Okay, there might be cases which is just like, for example, we have banks. Yeah.
What's PII?
PII is like personal identified information, right? So you might be asking the question for the user for a chatbot on your public website. The public website knowledge is already public. You are just helping the thing. So if the security is asking, oh, this data is going out. Why? Because this is already public. Even the search engine is crawling that. So what was the big problem? Okay. So that thing. The other thing is if it's PII data, okay, there can be multiple things. Either you wait for that, or for example, you can deploy these LLMs on your own personalized GPUs. Your own personalized GPUs in the region. For example, you can deploy these models on Databricks. You can deploy on separate GPUs, but it will not be OpenAI. It will be the other model like Llama, like Mistral, like all the other models. And we can give you Phi and Phi 3, which I'll be covering in the sixth week. Okay. But this, if you don't require OpenAI, but just an LLM, we can provide that on a separate compute. But you have to
Just
have GPUs.
start for the regulations. Try not to assume things. Take contact with us because we already work with the regulations. We already run many workshops with, for example, Qatar Central Bank. They have understanding. We work with other like financial institutes. Some of them, by the way, they're already using it. Like in the financial sector, they're using OpenAI in outside the region because they understand what is the regulations and some of these institutes, they have workloads running outside Qatar. It depends on the data, it depends on the case, it depends on, so we can help you and have an understanding and evaluate your case and see if this thing can be deployed.
Yeah.
I have a question. Can you hear it out?
API works with the stream functionality from OpenAI. Okay. Very good question. There is like, I was covering the latency problem, right? The latency that, for example, how much time it takes. There is different technique how you can improve the performance. If you look into any models, there is some time when you ask a question and the response is very big, either you wait for the whole response or you just like start to working on this. Like it will say the first, the capital of, like it will stream the data. So the question is, well, if I put this boundary in there, whether I can have the streaming API in there or not. I haven't looked into myself, but I'll check that and get back to you. But I think all these APIs, even the stream APIs, are behind the out of the box like the APIM. So I think it will be supported, but I'll check and then give that example afterwards. Okay. So I'll ask a question. Okay, and you let me know which service will this be. Consider there are 2 pizzas, okay? And Fateh or Argo, you are restricting that Fateh can only eat 1 pizza and not 2, and Shir can only eat 1 pizza and not 2. How would you like restrict that with which technology? How would you say that, for example, one person should not go beyond 1 pizza, let's say? So if I define like the compute power, let's say you have compute power and you just say Shir should not abuse the whole compute power or Fateh should not abuse the whole compute power. So which service will you use?
The pizza balancer.
Yeah, pizza balancer, like I was referring to APIM, right? Because you have throttles. So you define, because when you have a lot of food, Fateh can start taking all the resources and Share will be denied. Okay. So the same way, this is that bottom, like the throttling part, which Fateh was mentioning, that if you have an API, okay, you just provide it half, that this user should not increase in here. That's how all the services are built here.
So you have things like policies in APIM. So these policies can be applied at the inbound traffic and outbound traffic. So all the traffic, it flows through the APIM layer. And once you start implementing these policies, what you can achieve is something like, authentication, how the request should be authenticated. Okay, throttling. You can add more security related policies, which will, just limit requests from a certain IP. It has caching policies. Now, caching with OpenAI is a very, this feature is new. So what it does is, for example, we saw multiple chatbots. Let's say 2-3 people are asking the same question. So when they all ask the same question, it is going to run through the flow. All of these tokens and everything will be generated. It will create a cost, right? So APIM caching can help us there. So if a response is already in there cached, so for other users, it can just simply pick up that response and provide. So this is also something that you can do with APIM, and there are like a lot of other things. You can publish your OpenAI APIs, etc., etc. But this is like not the point, the topic that I want to discuss. But further, just to add a few more things, this architecture that you see and the previous ones, these are based on PaaS services. Mainly, we've seen Azure App Service, but you can have microservices as well. So now we are looking at Kubernetes services in Azure, or you can say ACA, Azure Container Apps, Spring Apps. All of these services, they host your containers. So now the next application that I'm just going to show you, it has like multiple microservices. So microservices are basically small applications, APIs that communicate with each other to build up an application. Should I move on, or
please? If you have questions, please do ask.
So
can I ask you like a funny question? How many of you guys think that like Fateh, whatever Fateh and I explaining is alien language? Huh? It's okay. Okay. If I was in your scenario a few years back, I was just considered this alien language. I don't understand whatever saying, but it's good that you guys are following up. If you guys are not even following up, after a few repetition, if you keep coming, you will learn this. It becomes like a habit. You will understand all these services. So yeah, keep coming. If you are even seeing that it's difficult, if you don't understand some stuff, it will come and you will understand the technology.
I would suggest that one of the things that helped me understand the artifacts of cloud is AZ 900 and AI 900. Yeah, you go to learn.microsoft.com and it's nice and you will understand most of the terminologies that we mentioned today.
That's great. That's great. So the learn part, I'll just suggest like after the session, we can give the learn part as well. And if you guys keep coming, probably I can see if we can get some free certification vouchers for you guys.
Okay, so this is basically e-commerce site, okay, and it has multiple APIs. These are small microservices, and it has a web app. So in the start, we saw like, we had a chat interface, but there are different scenarios where you can, you will have a AI use case. So for example, let's say you have an existing application. How can you build a chatbot on top of it? That can be a use case. So for something like that, I mean, so this is like a chatbot layer, which is built on, you can say, on top of an existing application. So it has, you can see multiple containers. It is spinning up all of these containers. These are Docker containers. And if I deploy, right now I'm running it locally, but if I want to move it to Azure, I'll have to go for some orchestration layers. In this case, it would be an AKS, Azure Kubernetes Service.
And this
So-
application is also publicly available with the source code. You can download and you can try by yourself. Actually, there is a book for this one also. Free book in the Microsoft website. It explains the architecture of this web application, microservice architecture.
So this is like the home page, and then you have a button. It pops up this interface to chat, and you can say like So basically, it tells you like what it can do. It can look into product catalog, which is a microservice, and bring that information and show it to the user that these are the items available. So let's say, so now if you see, it answers like, it has these kind of items in the Adventure World catalog. Now what's happening at the code level, it is getting this information from a data source, okay? And it is using something, what we call function calling. This function calling is built in within the application, and using these functions, we basically interact with catalog API to pull the current data that we have, and then in the application logic, show it here using the AI system that we have. So like this is also something that you can build to add multiple extra functionality. So this is the application, and it can do more stuff. It can add things to a cart for you, etc., etc. So behind the scene, it is just calling the cart API and putting your item into the cart. So looking at I'm not going to go deeper into the code, but just to give you some idea, you can see like these are all the APIs that they're currently running and everything. And we have this chatbot folder where we have all these like 5 files that are doing everything for this.
And here, if you switch back to previous screen again, actually what it is doing, the same thing what we show in the first demo, right? It is doing a REST request to the backend service, and then response back to the user. So there is a couple of things that you need to set up. The first thing is endpoint address, again, which endpoint he needs to communicate, because he's going to send the request and reply back to the response, right? Get the response back. That's the first thing. And then there's also method here that it was they're here actually to send this request to this endpoint. That's the basic. Just the user interface is different. They just make it more shiny, looks good. But at the end, it's just a REST request to the endpoint.
I mean, this repository can also be shared with you, and in order to deploy this, it's the same thing. You will have all the steps if you want to deploy it. There'll be like 4 or 5 steps. It will have infrastructure as code template, which will deploy the infrastructure for you. And on top of it, you can then deploy this application and test it from how things are working. You can look into the code that I showed you how the function calling is happening. It's kind of a good approach. So the next demo we have is based on RAG. So
yes, there's a question, Simon.
If the LLM can interact, for example, with this website, can interact with the website itself. That's possible, like, can I tell it, okay, add this item to the cart?
Yes. Yes, you can do that. That's what we actually explain. So let's say you have a catalog database. So you can create a vector index, which will store those information for you. So you can go ahead and use this Azure AI search, fetch that some data from the website itself, and then you can create a relation between this data with the real data in the web itself, website itself.
So it has the ability to recognize, for example, if I tell it similar to like Alexa or like those.
It's a function call, and you can update the website using JavaScript. Right. So you can run JavaScript code on the browser and update whatever you want.
If I ask the model itself in the chat, it's like, okay, add this item to the cart, will it be able to call the backend and do it on its own?
Yes, and also there is another concept we haven't mentioned here, but it's called semantic kernel. Semantic kernel is another library that we are working on it. Microsoft is working on it, which you can use these AI services in your code. So instead of working with a static data, you can use the semantic kernel to work with your vectoral database within your code. So I also encourage you to go and check the semantic kernel for such scenarios. It's a more advanced library to do this kind of tasks for you.
So guys, this is like a RAG sample, and before showing you the code, I will just like briefly talk about what is happening here. So we provide our own data.
So what can you first ask if people know about RAG? You can explain it, but it's better to ask and explain it as well.
So,
Additional data that are missing from ChatGPT or the module that we're
Just repeat it and make sure that everyone understands it.
She explained better than me.
Yeah, thank you. Yeah, so just to let you know, right, RAG is like what we explained from the start, right? Like usually the model will not have all the memory. You have to provide it your own knowledge, and that's what RAG pattern is. Okay, so that's what someone is explaining. But I just want to make sure that you have everyone is understanding what RAG means and things like that. So yeah.
So before diving into Azure portal, I just want you guys to see like we have these PDFs, and this is like in this case our own data. This PDF, they have information related to, if I can open the PDF here, I'm not sure. Yeah, so let's say it has information about London, city, and stuff like that. So how we can know, how we can tell our application that this is the data, and then further, ask questions based on this data. So this is like what you can use for building, your tools and applications, which can be used for your company enterprise internally. So for this, the main thing is that the main components basically that are being used for this purpose is AI search. So AI search basically, does a lot for you. For example, it takes care of the chunking, creating the embeddings, and storing the embeddings. Shade explained all of this in the first two lectures, what are all of these concepts. But these capabilities are built in Azure AI Search. So,
And one note, previous name of AI search was cognitive search, right? They rename it as an AI search recently. They are same thing.
so in this demo, I'm taking you to the Azure portal so you guys can see as well how easy it is to do this basically. So simply I'm creating a vectorized index. Okay. So for that, I just click here, import and vectorize data, and I need to provide a data source. So all of these PDFs which I showed you, they are residing in our storage account. So from there, you can just choose a storage account, say, this is the folder where I have all of these PDFs, and I can hit next, and eventually it will end up indexing all of these PDF files and then store the index for this data. Okay, and the other component that we have is our Azure OpenAI model, which will be used in the similar way. We will send this data through the application to the LLM, to the OpenAI, and we'll ask OpenAI to give us an answer with this data. So this is what you will see.
Now, this time our user interface is a Python user interface, but eventually it's doing the same thing. It's just sending the request, receiving the response.
Yeah, so I'm just going to ask, what is the most, what is London mostly popular for? So we can see this answer.
Or you can ask the hotel suggestions, for example.
Yeah, go ahead, please. Yeah, great question. So either, for example, there are two parts, okay? You can ingest the Arabic as it is, okay? As your question needs to be coming in Arabic as well. If you vectorize it, vectorization automatically understand multi-language, okay? Or the best part is that, for example, I explained in the first session about the token concept. In Arabic, it will be a bit slow because each alphabet will become one token. So what you can do is either you translate that, but there can be different problems as well in translation. You just maybe say that, for example, this translation is not good, but yeah, you can ingest the data in Arabic form, no problem. You can if it's Arabic, if it's mixed, okay, you can also do that. Like it will respond in mixed language, but I would suggest that to have a clearer answer, you just set the context, whether it's in English or Arabic, and then you just ask in that language and not do a mix. But if your scenario is mixed, I haven't tried it out, but yeah, you see most of the chatbots set the language in the start, and then you conversate in that language. Okay. One more question.
So right now I'm working on a RAG application, and my biggest challenge is chunking the text because I have lots, like hundreds of pages of text. Is there a good Azure product to help me chunk? So specifically, I want the text split into the topics, like logical topics, and then I want the things like headers and footers and table of contents to be stripped.
Yeah.
Is there a good product for this?
So a really good question, right? Out of the box, there is nothing as such. Okay, if you use the Azure OpenAI as your vector database, okay, it will automatically do chunking. But the chunking is also like a concept. The easiest way is you can just go with the out of the box, but it might not work in all the cases. That's why you have to go to the advancing, and that's what you are asking. How can I know that, for example, what is the technique, what you should do? So based on your data, you need to understand what are the topics which are related, how I should chunk it, okay? Usually the default language, the way that I'm doing it, I just like remove the garbage characters, okay? That's the first pre-processing. Afterwards, like the maximum limit you want to do, like I would say that if the maximum chunk size is, let's say, 8,000, let's say, tokens as an example, I would suggest keep like around 3,000 of tokens as chunk. Okay, but the chunking doesn't mean that it should be discrete. You should not have a discrete chunk, chunk 1 and chunk 2 and chunk 3. There might be topics which are split on multiple chunks. Okay, so you should have an overlap. Usually the recommendation is 20% of the token should be overlap between the two chunks. Okay, so it knows that this chunk is related to this for the same topic. Otherwise, it will not know what is the context. Okay, but this is a complex topic. It's like when you look into like advanced things that like how I can do this, this requires custom cleaning and custom processing and what to do this and this like that. So there is not like the generic guideline is just like a pattern if you have an advanced case.
Honestly, what I'm doing now, because I did try like recursive character text splitter, but my documents, they vary a lot. So what I'm doing right now, I'm actually using I made an agent. So I'm using the AI to help me like figure out what's a topic and then break it up like that. But there's a concern around the output token limit. So, I mean, that's the best approach I've found, but there's still that limitation.
So we can have a discussion on this. I can have a separate discussion on details on this. Yeah.
Yes, one GitHub repository. Again, it's a public open source, but backed by Microsoft. There's a open source project inside that one which will automate this chunking process for you. Supports multiple file formats like TXT, PDF, JPEG, so on and so forth. Personally, I haven't tried it, but it made me remember at tomorrow in either WhatsApp channel or our LinkedIn. I will share this GitHub repository with you, so check this automation tool also. Yeah, it's a public source tool, but as I told you, I haven't tried by myself.
Because honestly, I found that the quality of what's being retrieved, it depends a lot on how it has been chunked initially.
Yeah.
Because otherwise you get like garbage
Yeah.
in here.
For an advanced thing, it is an advanced problem. Like the chunking is a bit difficult. Yeah. It seems simple, but when you go into this, similar to prompt engineering, right? Prompt engineering in the start, you just say, I have to just instruct. But when you guys are stuck, then you have to like fine tweak and things like that, and it become like very hard as well.
Yeah, so that's it. I mean, we got the response from the PDF document. So if I start asking more questions, it will just generate the answer from the PDF. So like,
As you can see, it gives the suggestions from the PDF, the Buckingham model, Stolder, Kensington. These are the answers from the PDF itself. But in this scenario, we are doing this flow inside the code. We are not using the prompt flow in this scenario. Instead of prompt flow, we are doing it inside the code. That's how it works. This is also publicly available source code. It's part of the Microsoft Learn, one of the Microsoft Learn Lab. Again, we will share this code with you so you can check how to use it. But eventually you need to upload these PDFs into AI search because we need a vectoral database at the background. And then our code will go to this vectoral database, fetch the data, blend it with the AI, large language model, and give the output to us. Good.
yeah, that's it.
Okay, there is one question which I want to answer. Sabat, can you just go to the AI Studio, please? And the first demo that you started, there was one question. Okay, when Sabat was showing the first demo, he asked a question, who is Bill Gates? And then we get a response. And then I asked an alternative question, can you translate the previous question in Arabic? And it responded in Arabic, but something else. Can you tell me why? That was the question, why it happened. Okay, and I'll explain that. Yeah, history. So there was one thing, like for example, the first question we asked, I just say translate the previous question in Arabic. Okay, in the parameters I have to check with the code, but I think we haven't like got the history in there. But if I just ask the same thing in the AI Studio, it will understand. And the second thing is, which was on the personalized information, I'll give that demo. I haven't done it, prepared it. I'll do it in live. So if it works, good. But if it doesn't work, I'll then apologize and I'll make it work. Okay. So what I'll do is, someone has an older model, so I'll just first create a new model. Okay. And I hope we have that. So I'm just creating. Someone is using GPT 3.5 Turbo. I'm just going to create the latest model, which is GPT 4o. So I'm just going to select GPT 4o. This one, I'll just confirm this. I'll create this model. And I'll just say create it. Okay, these are the different settings which you can use, but I'll just currently deploy this as is. Okay, these are the different models, and I'm selecting this one because this has like more powerful. So that's why I'm just trying to use that. Okay, so I'll ask the same question which we did. Who is okay? And this is now coming from the knowledge, not from the Wikipedia. Okay, so let's see if it knows. Okay, and it might give some source. It might not give because there might be multiple sources that is in here. Okay, so this is the response that is giving. Please respond to the previous question in Arabic, and let's see if it will. Oh, error. The model maximum contact domain is this. I think maybe the token size is there, but I'm just going to check and do pay history. Okay, so let me do a simple one. Okay, who is let me what is the stock price of, let's say, just say Microsoft for now. Okay, and I'll just say, please respond to the previous question, previous question in Arabic. Okay, let's see. Okay, this already responded, like the question. Okay, Microsoft, it understood that I'm asking from this question. Come means like how much? I think a lot of people, I'm learning Arabic, so that's why I know. Sharika, Microsoft. Sharika is company, Microsoft. Okay, so I explained that. So it understood. And why this is happening? Because the parameters, if you see here, we are passing up the history. If I didn't pass the history, it will not understand what is previous question and what is this. Okay, that's the first thing. The other thing before we wrap up, if I go back to the sorry. Okay,
Salah, Shasha, there's a question.
It replied to that question. Please respond to the previous question in Arabic. Should give the response, but give that question back.
Yeah. So it is just like translating the language in in Arabic. If I just say that, for example, okay, like this, okay. Sorry. I have a question because I asked, what is the? Oh, please respond to the previous question in Arabic. It just given me the question in Arabic. If I ask the same question in Arabic, it automatically